All right, so today we're going to talk about the correlational method of research. So this method tries to express a relationship between two variables. So when you are trying to establish correlation, you need to ask yourself, does the value of one variable systematically change with the value of the second variable? Correlation itself cannot be used to prove causation. I will say this probably 10,000 times this school year. Correlation does not equal causation, okay? So just because things seem to go together doesn't mean that one causes the other. Just because two variables are related to one another, you cannot assume that one of them causes the other to occur. They could both be related to some other variable or the cause that is the cause of both of them. And so we are going to see an example of that in this video. In this video, we are going to see that correlation does not always equal causation.
Well, hi there, boys and girls. This is Captain Kangaroo. Say, I'd like you to meet a friend of mine. So, you know, it's lots and lots of fun to have a pet you can run and play and jump with, isn't it? But did you know that there are some boys and girls who can't run and jump and play? It's all because of a thing called polio.
When I think of bad historical assumptions about correlation and causality, I think of polio 100 years ago, when it was this horrible mystery that it was, claiming a lot of lives, and it was really scary because it mostly struck children. And there was a strong line of research that suggested that ice cream caused polio, that ice cream consumption caused polio.
Here comes Mr. Softy, the soft ice cream man. The creamiest soft ice cream you get from Mr. Softy.
The reason that correlation was thought to be causal was that polio spiked in the summertime for reasons that really weren't very well understood, but it did. And ice cream sales spiked during the summertime. So these researchers had seen that whenever there was a lot of ice cream being sold and consumed, there was a lot more polio. And so there was really literally the beginnings of this kind of ice cream persecution to try to stomp out polio. And it sounds ridiculous, but you see it all the time now, of people trying to fight against or build up something that they're sure is connected to something else, which it turns out just isn't.
So as we saw from the video, they thought because ice cream sales went up, that polio cases went up, that ice cream caused polio, but that's not necessarily the case. They both tended to go up in the summer months. There's another study that said that ice cream caused murder. So does ice cream cause murder, or does murder cause people to eat ice cream? Because ice cream murders go up in the summer, ice cream goes up in the summer as well. So is there a relationship between ice cream and murder? And the reality is there's actually a relationship between summertime and the eating of ice cream and murder, okay? So just because ice cream goes up in the summertime and murders go up in the summertime doesn't mean that eating ice cream causes murders. Correlation coefficient is represented by the letter R, and it is going to measure the strength of a relationship. So if two things are not at all related, like, by the way, are ice cream and murder or ice cream and polio, then the relationship is going to have a 0 R, or a 0 correlation coefficient. If the decrease of one thing causes the increase of another, if let's say ice cream, if people eat ice cream and it causes murders to go down, that's going to be a negative correlation, okay? If people eat ice cream and murders go up, that would be a positive correlation, okay? So the correlation is either positive or negative, but there's still a correlation there. So there's still some sort of link between the two there. So it doesn't necessarily mean, so for instance, the stronger correlation here is actually negative 0.72 instead of positive 0.59. So look at the number, not the negative or positive. Which one is the larger number? That's going to tell you the stronger correlation. Because negative just means that the inverse happens, like one goes down, the other one goes up. A positive correlation means they both go up together. Okay, so you can take a look at these and see if you can do any of these on your own. Remember, look at the number. So here, negative 0.65 is higher than positive 0.48 because 48 is smaller than 6.5. All right? Researchers want to know whether or not cigarette smoking is connected to life expectancy. So obviously the scientists can't hang around and people who smoke and wait to see if they die. The only way, short of performing a really unethical experiment, is to find out if they are related, is to use medical records of people who have already died. So you go through the medical records of people who have died and isolate the cause of death, see if they were smokers, see when they died. So researchers will look for two things: the number of cigarettes a person smoked and the age of their death. That's all they're looking at, okay? Now the researcher has two sets of numbers for each person in the study that go into a formula, which I'd never ask you to do, to produce a correlation effect. This is the direction of the strength. So let's just say, oddly enough, that if you smoked cigarettes, your lifespan increased, okay? So that would be a positive correlation. If you smoked and your life expectancy decreased, that's a negative correlation. If you smoked and your life expectancy remained the same, that would be a zero correlation. Okay, so you have a positive correlation. These are when the variables go in the same direction. Studying and grades will go in a positive correlation. The more you study, the better your grades, right? Inverse correlation is when the variables go in opposite directions. So heroin use and grades probably has a negative correlation. If you're a big heroin user, your grades probably are negatively impacted, correct? All right, and weak correlations indicate little relationship. So they're not quite at zero, but they're very close to zero. Now we show these relationships on a scatter plot. Now I will not ask you to create a scatter plot, but I may ask you to read one. This is an illustration of possible correlations. And what they typically do is they typically draw a best fit line. So as you can see, this is a very weak correlation because these are all kind of randomly scattered. They drew a best fit line, but that doesn't take into effect these and maybe some of these higher ups, right? But this is strong positive. They all lie along this line. This would be a strong negative, right? When you're looking at a scatter plot, you want to see which direction this goes in, up or down, up or down. So this is a positive and a negative. And then how steep is that slope right here? Or how many data points do you have right on the line? Because the more data points on the line, the stronger the correlation. Now, sometimes the perception of there's a perception of relationship where there isn't one, and that's called an illusory correlation. So when we believe there's a relationship between two things, we're more likely to notice and recall instances. So this is a form of confirmation bias. Like we're likely to look at information, or we're more likely to notice those things which tend to prove our correlations than notice the things that don't. When we notice coincidences, we may forget that they're random instead of seeing them as correlated. Random sequences often don't look random. If you flip a coin 6 times, you could get this or this or this. All 3 are just as likely, but you would think that this one was super random while this one is more normal, right? But the reality is mathematically, they're both all 3 of them just as likely to occur, okay? With a large enough sample, any outrageous thing is likely to happen. That's why we draw a best fit line on the scatter plot. We don't necessarily take every single data point into account. Any event that happens can happen to 1 in a billion people every day. You think of an event and somebody somewhere is going to have that event happen to them. That doesn't mean that something is caused. It means that that was a coincidence or an odd thing that happened. All right, so that's where we leave off with correlations.